Hi there. We are going to talk about section 4.6, lines of symmetry. So you guys are going to turn to page 275 in your book. And a figure has symmetry if there exists a rigid motion, could be a reflection, translation, rotation, or a glide reflection that maps the figure onto itself. Figures that have symmetry are self-congruent. One type of symmetry is line symmetry, and that's what we're going to be looking at today. A figure has line symmetry if each half of the figure matches the other side exactly. So if you folded your paper along the line of symmetry, each half matches each other exactly. The line of symmetry, or that reflection line, is what we're going to be looking at today. All right, so let's look at the example. How many lines of symmetry does this 1, 2, 3, 4, 5-sided figure have? That's a pentagon. So we want to look if we folded in half our lines. So we folded it in half here from the apex to the middle of the other side. You can see that this corner matches this corner, and this slanting line matches this slanting line, as these ones do as well. But if you orient it the other way, so we say, okay, I'm going to go through here. There's also a line of symmetry here. One here. And one here. So this one has 1, 2, 3. Oops, let me get my pointer. Apologies for that. So this figure has 1, 2, 3, 4, 5, 6, 7. Sorry. 1, 2, 3, 4. And we're missing one more. Oh, it's right here. 5 lines of symmetry. Make sure when you're doing like what I was doing, you count around. So start 1, 2, 3, 4, 5. I'm not going to count this one again because I already counted him. So this buddy has 5 lines of symmetry. This scalene triangle, if I tried to make a line of symmetry out of him, like, oh, well, no, that doesn't work either. So a scalene triangle, which is a triangle none of the sides are the same, has no lines of symmetry. Okay. All right, now your turn. We're going to pause this video, and you guys are going to do this little check right here. When everybody's ready, go ahead and unpause this video, and we will look at the answers. All right, this one has, a rectangle has 2 lines of symmetry. One that goes horizontally, and one that goes vertically. Okay. So a rectangle has 2 lines of symmetry. This triangle here, we definitely see if we just put one in the middle, he's going to have this line of symmetry, but the following, it's also true through here and here. So this triangle has 3 lines of symmetry. And then this trapezoid, there's really no way I can put a, there's nothing, there's no line that I can make. Like if I did it diagonally, we would still not match up this way. If I did it diagonally this way, these halves wouldn't match up. Straight across, doesn't match up, and nor in the middle. So there's really no lines of symmetry that will make this work. So we say 0. All right. Rotational symmetry. Woohoo! Rotational symmetry is where a figure can be mapped back onto itself by rotating less than 60 or 360 degrees. So, of course, if we go in a full circle, it should map back on itself. But these special figures that have rotational symmetry, when you rotate them less than 360, end up matching back onto themselves. The point in which the figure is rotated is called the center of symmetry. And the number of times the figure maps onto itself between 0 and 360 is called the order of symmetry. And the magnitude is the smallest angle that the figure rotates to map back on itself. So the magnitude, so the order is how many times, and the magnitude is the angle that will map, the smallest angle that'll map itself onto itself, map the figure onto itself. So for example, if we have a square right here, we're going to take this corner, rotate him 90 degrees, and he's going to match up back onto his other corner. So this square has a 90-degree magnitude, and if we look, we rotate it once, maps up onto this corner, rotate it twice, maps onto this corner, rotate it 3 times, this corner matches to this corner, and we rotate it 4 times and it comes back to itself. So the figure has an order of 4, so it maps onto itself 4 different times between 0 and 360, and his magnitude is 90. Okay? So a figure has point symmetry if it can be mapped, point symmetry, this is different. So point symmetry if it can be mapped onto itself by rotating 180. So remember, 360 is the whole thing, 180 is half, and it has point symmetry if you rotate it that 180 and you are back mapped onto itself. One of the tricks is it looks the same whether it's right side up or upside down. All right, in nature, there is a bunch of rotational symmetry. So let's look at these little shapes right here. And if you're following along in your book, we're on page 277. And we look at this leaf. If I had my center right here and I rotated the leaf, it wouldn't, this point doesn't, you can see the little pieces of this leaf are different from here to here, so it doesn't really rotate onto itself. So he has no rotation symmetry, so he gets to be no. But this little flower here, you can see that this petal looks like this petal, looks like this petal. The middle is a circle. A circle can be the same no matter how many times you rotate it around, partial or full. So let's go ahead and count. We have 1, 2, 3, 4, 5, 6, 7, 8 petals. So this one is going to be yes. And then we're going to say that the petals, sorry, I can type faster. The petals map onto each other. Okay. All right. And then we have this little 4-leaf clover here. Good luck to you. And we can see that each of the petals of the 4-leaf clover are the same. They're this little heart shape. Their inside part is the same. So this one also has rotational symmetry. So we're going to say yes. The leaves map onto each other. All right, let's look. It's your turn. You guys are going to tell me whether this orange, these scissors, or this television screen has symmetry. Take a minute, pause. And then when you're done pausing, go ahead and check it. All right, this orange is a yes. The slices map onto each other. These scissors, it's a no. These scissors are a no because you can see this handle is a different shape than this handle, so even if I flipped it around 180, it still wouldn't match up handle to handle. So we have to, for this one, we have to say no. The handles don't match. Okay, and then this little screen right here, he is going to be a yes because he is a rectangle shape, and we saw that the rectangle shapes do have symmetry. Rectangles have rotational symmetry, even if we just did 180. Now, some of you guys are saying, but Miss Applegarth, there's this weird shading difference. Ignore the shading difference, just look at this shape. This is meant to make it look more realistic. All right, so the hardest thing you're going to do in this section is to determine order and magnitude. So let's take a look at some different figures and see what the order and magnitude is here. So I have a 1, 2, 3, 4, 5-sided figure. All the sides are congruent. Does this have rotation symmetry? The answer is yes. And the order is, so remember, order is how many times it rotates and meets back onto itself. The hexagon, we drew those, so this corner meets up with this corner. That's 1, 2, 3, 4, and then 5. So it has a order of 5, and its magnitude is going to be 360. That's how many degrees, and we're going to divide that by 5. 360 divided by 5 is 72 degrees. Okay, this little buddy here, we go, like if I drew a line, it's that trapezoid problem. If I draw a line here, or up and down, or even, not even diagonally, can I draw it? So the answer, does it have rotational symmetry? We have to say no. So that means it doesn't have an order, and it doesn't have a magnitude. How easy is that? My lucky day. All right, this little parallelogram here, if I were to flip him, so if I were to flip this corner 180 degrees, rotate it around, this corner, rotate it around, so that it matches up back to this corner, that is rotational symmetry, so we say yes. It has a order of, so it flips around once to get to here and flips around again to get back onto itself. That is 2. So 360 divided by 2 is 180. And then which figure in part A has point symmetry? So, and justify your reasoning. So we're going to say the rectangle. Because the definition of point symmetry is that it has a magnitude of 180. All right. You guys, that is the end of this lesson. After you do this check. Okay, so take a pause. Pause for a minute, and then you guys go ahead and check. All right, so the answers to the check are yes, no, and yes. The rectangle has an order of 2 and a magnitude of 180. no rotational symmetry, no order, and no magnitude for this kite shape here. And then rotational symmetry here, yes, this point to this point, this corner to this corner, and this corner to this corner. So it has an order of 3 and its magnitude is 120. Which figures have point symmetry? This first rectangle A, it has a rotational symmetry of 180 degrees. And that's our, you guys go ahead and take a minute, probably closer to 15, and complete this assignment from page 279. Thanks for joining today.